Hey, this is Mr. Zhu and Mr. McDonald. Here's our first exercise on matrices, and matrices are a method of storing values in the form of a table. Here's our learning intentions to introduce key features of matrices, as well as simple operations with matrices. And what we need to do is be able to add and subtract them, as well as multiply matrices. Here's an example of a matrix. By the way, a matrix is an array contained in a set of brackets as shown below. So these are just numbers. An example of reading off this array would be the example Ashley is 23 years old, and Ashley also has 5 pairs of shoes. The entries in there, which are the numbers, they can be called entries or elements. Matrices can come in different sizes, and we need to be able to describe their size. And the way we describe their size would be the number of rows by the number of columns. So rows are your horizontal lines, and here we have 1, 2, 3 rows. And we've also got 2 columns, 1, 2. So the way we describe the size of this matrix would be rows by columns. That would be 3 by 2, a 3 by 2 matrix. Similarly, for the rows, there are 1, 2 rows, and for the columns, 1, 2, 3. This would be a 2 by 3 matrix. Now, what's important is that if you've got matrices of the same order, that means they've got the same rows and columns, and if they equal to each other, that means we can equate the entries. So as an example, find the elements of set B. So here's set B. We look at the corresponding entries. In this case, A is equal to 1, B is equal to 0, and you can read off the others as well. C is 2, D is -1. So in other words, we can rewrite matrix B as 1, 0, 2, -1. If we haven't mentioned it yet, matrices can be described with a single capital R. Here's a practical example of how we can use matrices. So here's my reading in the month of June, my paper reading and my online reading, and the types of paper and online reading as well. This table can be written in matrix form. Notice that we've got a 3 by 2 matrix here. In the same way, I can build a table for July and also make a matrix. Here's a question for you. What would it mean for us to add these numbers in the matrices together? What do we get? So to answer our question, in other words, the addition of matrices, we can perform that now. I'll rewrite the matrix down, 2, 4, 3, 1, 4, and 5. Let's make that a better 3. And we add 3, 2, 1, 1, 5, 3. So the way we add matrices is to add their corresponding elements or their corresponding entries. Our resulting matrix would be the result of adding 2 and 3 together, which would be 5. Adding 4 and 2 together, which would be 6. And we can do the same thing for the others as well. 3 and 1 is 4, then 1 and 1 is 2, 4 and 5 is 9, and 5 and 3 is 8. So we've done just an example of adding matrices. Let's interpret what this means. So that number 5 there, remember, that fell into the entry of paper and fiction. If we add these matrices together, that tells us the total amount of reading that I've done in June and July, and that would be 5 fiction paper readings. What I'd like you to have a go at is to attempt the subtraction. The rules are exactly the same. All you do is find the difference between the elements. Pause the video, have a go, and we'll reveal the answer in a moment. Notice that when we're adding or subtracting indices, their dimensions must be exactly the same. In addition, the resulting matrix will also have the same dimensions, which means if we have matrices of different dimensions, we can't add them together. In this example, we're going to look at what happens when we're scaling up a matrix. So in this case, we have our matrix and we multiply it by this multiplication factor. Now let's interpret what that means. Timesing by 3 is the same as repeated addition 3 times. That's the same as writing an addition problem. 1, 2, 3, 4. 1, 2, 3, 4. And what we know about adding matrices is just the fact that we add the corresponding entries together. So what that means is I've got 3 of those 1s, so that's 3. 3 of those 2s is 6. 3 3s are 9, and 3 4s are 12. Notice that we can get straight to the answer just by multiplying each of these entries by that number. So the shortcut is just timesing every of these entries by 3. 3, 6, 9, and 12. And notice that we get the same answer.
Okay, hi everybody, my turn for today. I'm going to introduce the concept of multiplying matrices. And we're going to just look at an example here of how it's applied, and then we'll look at the algorithm, and then we'll talk about the conditions for the algorithm. So to begin with, this is an example of where different types of pies were sold over the week. So on Monday, 13 apple, 8 cherry, and 6 blueberry pies were sold, and they each have their corresponding values of how much they sell for. So as a very quick test, what was the total cost on Monday of all of these pies? Just pause the video and have a go at answering what was the total cost of those 3 pies sold on Monday. Okay, so using matrices, if we multiply each of them together, 3 times 13, then we get the total cost of apple pie, and then 4, which is our cost of cherry, multiplied by 8, and then added that together with the cost of apple, and then lastly, the cost of blueberry, multiplied by how many we sold. If we add all of those results together, what we're going to get is, on Monday, we made $83. So hopefully that's the number you came to. The significance of this is that we can actually perform all of these calculations in one go. So we can actually calculate all of the cost or the revenue made on Monday, Tuesday, Wednesday, Thursday individually in one process. And that process is using matrix equations, and that's what we're getting to in this topic. So let's look at the algorithm first before we start talking about some conditions. Jot down this example. Example 1, let A equals this matrix here, and B equals this matrix here, and you're being asked to find matrix A, B. Okay, and we're going to have our answer in the form of a 2 by 2 matrix, A, B, C, and D. So I'm going to step through the calculation for A first, and then B, and then C, and then D, and we're going to put it all together in the next slide. So we calculate position A, so this top left position, by multiplying together 1 and 2, 1 times 2, and then adding that together with 3 times negative 1. Just like with our pi example. 2 plus negative 3, negative 1. Let's do C, why not? That's right here. 4 times 2 plus 4 times 2 plus negative 2 times negative 1. 8, take away, or 8 plus 2 is 10. Our B over here, 1 times 0 is 0, plus 3 times 5, 15. So a B value is 15. And lastly, a value for D here, 4 times 0, 4 times 0, plus negative 2 times 5, negative 10. So what we've done is we've found that A here is negative 1, B is 15, C is 10, and D is negative 10. So we have a result where we've performed all those 4 calculations in one go.
Before you move on, I'll just highlight the importance of multiplying a row by a column. And the answer turns out to be the part that overlaps. This row times this column is the first row times the first column, and that's equal to the first row and the first column of our answer. In the same other examples, the overlap, the first row and the second column, tells you the answer for the first row and the second column as well, and so on. That's how you got the elements in the product.
Okay, so formally we could write our solution like this. A times B is equal to this first matrix A multiplied by this second matrix B. And our answer here was square bracket 1, 15, 10, 2. So formally, there's our answer. Okay, so let's have a go at example number 2. Given that M equals this matrix here and N equals this second matrix, calculate matrix Mn. So this is formally asking us to perform this multiplication of matrices. So let's write down our matrices. Mn is equal to, so I'm assuming here that the calculation can be performed. The significance of that we'll get to in just a moment. 1 minus 1 minus 2, 2. 0, 3, 1, 2. Okay, so let's perform the circle part. 0 times 1 plus negative 1 times 1. And now our bottom left position, negative 2 times 2. Sorry, negative 2 times 0, I should say. Plus 2 times 1. So 1. 7. Our top right position, 1 times 3 plus negative 1 times 2. Close the bracket because it's not going to go further than that. Negative 2 times 3 and 2 times 2. So there's the full working, the full algorithm that is performed in one step when we use CAS, which will then tell us the 4 entries at once. 0 plus negative 1, 3 plus negative 2, negative 0 plus 2, and negative 6 plus 4. So we have the result of multiplying together M and N, and it's this 2 by 2 matrix here. We're going to have a look very quickly at what happens if we multiply N, M, because intuition might say that if we reverse them if we multiply them in the reverse order, the answer should be the same, just like with numbers. But with matrices, we're going to see, is that actually the case? Okay, so N multiply. So as you can see, Mr. Zoo's just written up the red, the red result from the last page. And what we're going to do is to see if, when multiplied in the reverse order, as is the case with numbers, will the result actually be the same? 1 minus 1 minus 2, 2. So these are reversed. If we then step through the algorithm, 0 times 1, 0, plus 3 times negative 2, that's negative 6. We can already see that our first position, our top left entry, is different. So let's just go through and step through the rest. 0 times negative 1, 3 times 2, 6. 1 times 1, 1, plus negative 4, negative 3. 1 times negative 1, negative 1, plus 4, 3. So what we've got here is as a result for multiplying the matrices N, M in this order, contrasting with the result for M, N in the reverse order. Okay, so the conditions I've mentioned earlier are as follows. 2 matrices can only be multiplied if the number of columns in the first matrix is equal to the number of rows in the second matrix. So for example, let's write down, or I want you to have a go at writing down the order, the dimensions of these 2 matrices underneath, and the dimensions of these 2 matrices underneath. This first one is a 2 by 2, 2 rows, 2 columns. The second one has 2 rows and 3 columns, 2 rows, 3 columns. And over here, we've got 2 by 2 again, and 3 rows by 2 columns. So, this condition is not satisfied for this right-hand example. And a very good way to think about it is the following. Circle, when they're in the correct order, circle your 2 inner numbers. If they match, great, we can perform the calculation. And the resultant matrix is going to be a 2 by 3. Over here, when we circle our 2 inside numbers, they do not match, we cannot perform the calculation. It is not possible.
I'll add on to that the fact that the reason why this works is, remember, we're multiplying the rows by columns. So A matches with E, B matches with H. That's all good. Whereas with the second one, A matches with E, B matches with G, and no one's matching with I. That's why the number of columns must match the number of other way around, the number of columns must match the number of rows. In the previous examples, what we've done was we multiplied just square matrices. In other words, they look like a square because they've got the same number of rows and the same number of columns. Now, in this case, we can also multiply matrices that have different orders if they follow the correct rule. So the correct rule is the fact that if you write them in order, now we're trying to figure out what CD is. I'll write that down. We've got this matrix multiplied by the other matrix, and if we write down the order of them, that would be a 2 by 2 matrix. Here would be a 2 row by 1 column matrix. In this case, we can multiply them together. So let's work through that. I'm going to multiply 2 by -1 and add on to that -1 times 1. So the answer is -2 plus -1, which is -3. In a similar way, -5 times -1 is 5, 4 times 1 is 4, 5 plus 4 is 9. And notice that our resulting matrix is a 2 row by 1 column, 2 by 1, which is the same as the outside dimensions that we written down earlier. So we've just covered addition, subtraction, and multiplication with matrices. You can do the exact same thing in your CAS as well. Now, there are CAS walkthroughs in your physical textbook on these pages. I strongly recommend that you follow those walkthroughs so you know how to do them on a test and exam as well. If you're working through a digital textbook, it'll be under exercise 7E, and where you see these green boxes up here and down here, all you need to do is click on them and that'll show you the walkthrough, that'll expand it out. So to summarise, what we've learnt today were the key features of matrices, such as their dimensions and simple operations with matrices. By now, we should be able to add and subtract matrices and multiply matrices. What you may like to do is work through those quiz problems on style and check your understanding.